Hello, everybody. I'm meteorologist Jeremy Wheeler, and it's time for the next WAVY Science Lab. We are talking about lightning today, and it's a fan favorite, and everybody, I think loves talking about lightning. So we're going to be talking about the structure of lightning a little bit. We're going to see some cool images, and we're going to talk about how, lightning comes from a thunderstorm, and we'll talk a little bit about thunderstorms. Maybe a future podcast we'll talk all about thunderstorms, but we've talked a little bit about the water cycle and at least how those form. So let's get right into it, and let's see what we've got for today. I got some cool images up here. So here's one of them. Oh yeah, look at all those lightning strikes. Now, in order to get that, a lot of photographers used to leave the shutter open on a great camera, a really high-powered camera. Nowadays, you can get video and kind of get the multiple strikes to come up that way. There's a whole bunch of tricks that I actually don't know, but it's really cool to see when it happens. It could be a time. It's not a time lapse per se, but just you're letting the light open there, the aperture open, and so really cool. Anyway, so this is our topic today, lightning, and it's mysterious lightning. It's so cool. Everybody loves to see it. But a lot of people don't know about it, the details of it. So it's amazing, it's beautiful, and yes, it is dangerous. I mean, it can cause health issues, if not death. In some cases, we'll actually talk a little bit about that. So, how does it form? How does lightning form? Is it flying electric eels? Is it Zeus? Everybody talks about the mythology, Greek mythology, and Zeus. And I actually read quite a bit about that, or magic, none of that. But still, it's always fun to talk about. So you need a thunderstorm, basically, right? You need a thunderstorm to form, and that's one of the main ingredients. And so for a thunderstorm to happen, you need some ingredients. And so you need moisture, right? Because you can have thunderstorms, in the desert Southwest, but they're more rare. And sometimes you can have dry lightning, which, you have a thunder bolt coming out of the sky, even though there's no rain, and that happens sometimes. But you also need lift, because thunderstorms love lift. And then you need those tall cumulonimbus clouds. So here's the different types of clouds, and this might be a whole podcast by itself, but you get nimbostratus to form. Those are layered clouds. Those don't often form lightning strikes, because you need the tall thunderstorm. You need lift. You need the air rising and sinking, and we're going to go a lot more detail into that. So on the right there, the cumulonimbus cloud, big thunderstorm clouds, and those things get tall. I mean, thousands feet tall. So here it is. We have we do this in the water cycle, but this is a little bit more in depth into just the lightning part of it. Excuse me. And so you got the warm, humid air, especially in the summertime, and that warm air rises because it's lighter. And so you also get evaporation. Well, to kick it off, the water in the lakes, the rivers and streams, it changes, gets energy, goes up into the sky. And so the next thing you know, you've got some cooling and condensation to form, right? Where the air rises, cools up in the sky. Now you got those little liquid particles in there, and then they get bigger, they run into each other, they start falling, and then you get precipitation. So that is the water cycle in kind of, in a nutshell, how it forms. Now, a thunderstorm needs, strong rising air, because you have to get that height. And so those thunderstorms, they get tall. Now, you get charge to build up. You get negative charge on the bottom, and then the ground is more positive. And so the opposites attract. They want to meet, and then eventually they do in the form of lightning. So that's the lightning strike. So in the lightning strike, or in the lightning in the cloud, here's what's happening. The updrafts, the air that's rising, lifts small water particles up, and these collide with descending hail and graupel. So hail is ice, graupel is ice. They're kind of just a little bit different. Hail happens in layers. Graupel is just kind of a mess, conglomerate. And so what happens is these collisions, these running into each other, the electrons get stripped from ascending and go to the descending. So when you have those electrons, that causes charge to build up. You get the positive on the top of the cloud, the negative on the bottom most of the time, and then the ground is more positive as well. Now, these regions collect more charge, and the charge builds. And that's important because, air is an insulator. So this charge, this potential has to build up in order for this lightning strike to happen. Because if it didn't, the charge would be dissipated. So your charge has to build up, and you got those opposites attract. And so, static electricity happens, right? You take the balloon And let's see if we can do this here. I don't know if we're going to be able to do this. I'm going to try this, attempt it. Let's see if we can do it. That was a failure, and that's because we need more hair. I think. I don't know, but I was wondering about that. But usually you can, rub your head, the balloon on your head, stick it to the wall, and it'll stick. Maybe I'll try it again a little bit. But the bottom line is static electricity builds up in that charge, and so then the balloon will then usually stick to the wall, which it did in this case. And then more hair may be a problem in that experiment. But anyway, after a time, the charge is released when it comes to lightning. So this is a supercell thunderstorm, a storm with a rotating updraft, and so that storm literally spins. And if it spins right and you focus that energy, you can get a tornado to form. I don't know if that happened in this storm or not, but this is a supercell thunderstorm with lightning, and lightning looks like it went from cloud to cloud in this case. So you can get lightning to do all kinds of different behaviors, but this is how it forms. So you get those electrons. They begin to zigzag downward. This is known as the stepped leader. So this is the beginning of it. And then as it gets closer to the ground, that charge starts to reach up a little bit from the ground. And so then it gets a helper, right? That stepped leader allows that charge to get closer to the opposite charge. And then the current flows. And then next thing you know, you get the charge going up into the cloud. Now that can happen that way. Sometimes it can happen the opposite way. It can happen in several different ways, and it can repeat. And that's the thing, go up and down several times. So that's, and it happens, less than a second. So this thunderstorm, you get, cloud to ground lightning, you can get cloud to cloud. So cloud to ground positive, that does happen sometimes. And I had an engineer once tell me that. He said that, the negative charges, and these are mapped as well. We saw the negative charges, and that's, a typical lightning strike. But sometimes if you get a positive charge, sometimes it would just go straight up without that step leader, I believe, and go into the cloud. That would be a mega lightning strike. And so the engineers were actually really worried about those. And we could actually see them when I had a radar unit in Huntsville, Alabama. I could actually see the positive and negative charges, and the engineer would be like, oh yeah, that's a bad one. So it's pretty neat to see. All right, so we covered a lot of ground here already. We're going to cover a lot more ground here coming up in just a little bit. So please stand by. All right, we're back, and I am happy to report that the experiment worked. There's the balloon. I have enough hair. Huzzah. All right. That's great. Thank you. Enough hair for now. So there it is. And so the static electricity allowed the balloon to stick. No tape on there. That was a old-fashioned static electricity. Okay, so let's go back to what we were talking about, and you can get those different types of strikes. And in the cloud. Here's a lightning strike that hits the ground. Very cool to see. I mean, look at that. It just lights up the sky, and then you can get cloud to cloud lightning. There's a good example of that. And you get those different charges building up in the clouds as well. So some lightning facts. It's only about an inch or two wide. That's right. It can be slightly wider, but only about an inch or two wide. Can be up to 50,000 degrees Fahrenheit, hotter than the surface of the sun. I think that's the potential. And we talked about the sun in another podcast, about 10,000 degrees Fahrenheit for the photosphere, I think. But the bottom line is it doesn't always get that high, because if it did, it would be melting objects all over the planet all the time. So I think that's the maximum that it can reach. And kind of depends on if you get hit with a side strike or the main bolt too. Sometimes they branch off. So that's a possibility. Anyway, can strike 10 to 15 miles from the storm. And if it's that trick works. If you count 5 seconds in between the time you see the lightning and hear the thunder, is about a mile away. The light travels almost to you and me instantaneously, but of course, very fast speed. But the thunder is much slower. So if you can count 5 seconds between the time you see the lightning and hear the thunder, it's 1 mile away. And then 10 seconds, 2 miles, and so on and so forth. But sometimes those things can strike so far away, it's hard to see. Or it's hard to hear the thunder. We'll talk more about that. Anyway, lightning history. The early Greeks thought it was a weapon of Zeus. they were just mystified by it, and they thought, oh wow, that's so cool. But hey, we could get hit by that. And Navajo Native Americans, lightning has great power in some of their healing rituals. Thor, God of Thunder, huh? I mean, he's a Marvel favorite. A lot of people love him. But he predates Marvel, of course. He just got roped into the series and everything, and the movies and the comics. But before that, he was God of Thunder and Foe of All Demons, and he played the game God of War. Right? He's a lot different in that game. He's a big, kind of a drunk, I think, actually, at one point. And hopefully you know what I'm talking about. The series God of War. Anyway. So that's some of the history. Now, some of the more recent history, Ben Franklin in the 1700s studied lightning and electricity, and he's very famous for doing those experiments. A lot of kids know about the kite and key experiments, which I don't recommend doing, but he did them. And, I don't know if he held the kite string while he's doing it, but even then it probably wasn't safe to do. But hey, he found out a lot, and so we'll take it. And also invented the lightning rod, which is very important. That has saved so many buildings, so many people. The lightning rod, it channels lightning straight into the ground, basically. So it'll be top of the building, it will have a connection all the way down straight into the ground, and it allows that lightning to go straight down. So some interesting history facts here, and this was from weather.gov, by the way, this factoid. The Napoleonic Wars, 220 British ships were damaged by lightning. I don't know the timeline, how long that was spaced out. I'm sure it wasn't in one day, but I think through a period of time. The French ships were okay, though, because the British didn't want to use the lightning rod, which was invented by Ben Franklin, who was a rebel, right? So time around the Revolutionary War, I imagine, as well. All right, so that's pretty neat, a little factoid there. Late 1800s, Alexander Popov developed a lightning detector. He based it off an early radio wave receiver, and then it sensed electromagnetic pulses, and that's how it worked. And of course, they're out there now. I mean, they're refined. There are sensors out there right now that can detect all these things, these lightning strikes. So here's a really cool one. This is from National Severe Storms Lab. I mean, of a tower getting hit. I mean, look at that. It's so vivid. And maybe they were inside and took the picture. I don't know. I want to be outside up on a mountain during that. Yeah, I mean, probably hit a lightning rod. I'm sure that had a lightning rod and went down to the ground. We have a tower here at the TV station, and that has a lightning rod on it. And it has been hit by lightning. Our camera's been hit by lightning. I don't know if it was the main bolt. There's multiple lightning bolts. It's cool. It's almost like Halloween here. Very cool to see, and it's so neat to see on videos and pictures of lightning, to just be able to see what nature can do, and just so powerful. And then you get the thunder, which maybe another podcast for that. So this is a cool one. I think it was from a plane in the distance. You see the lightning, and it's nighttime, so you're seeing the lights of the cities below. Here's another one, multiple lightning strikes. Again, just really cool. Looks like maybe a step leader came down and didn't connect. I don't know, on the left. But bottom line is, very cool stuff. And here's another one. So multiple lightning strikes. And these strikes, I mean, they strike down and, hit the ground sometimes. Sometimes they hit buildings, and that causes problems. How it's tracked, Lightning Detection Network. This is owned by Vaisala. And I don't know if it was separate. I remember them buying that out at one time. I don't remember it was separate and federally owned a long time ago. I don't remember that. But it is owned by Vaisala. Using an array of sensors across the country, some of the little devices we kind of just talked about, but refined. And then there's actually satellites in space. There's the geostationary lightning mapper that can actually detect lightning strikes from space. And then there's the GOES 16 and 17, two satellites up there. It's on there, I believe. It's on them. And that's geostationary orbiting environmental satellite. Those are weather satellites that are stationary over, the planet in some places. And then they of course give us weather information, but also can detect lightning using the geostationary lightning mapper, the GLM. All right. So very cool stuff. All right, let's move on. And so in order for a thunderstorm to form, you can't have a storm collapse on itself. So, you've got rising air, the updraft, and sinking air, the downdraft. And so in a thunderstorm, you need an ingredient called shear. For for hurricanes, they don't like shear, but for thunderstorms, they do like shear, especially, to grow, because otherwise what'll happen is the thunderstorm, the rising air will come up and then the sinking air will cut that off. Well, what you need both to be able to keep going at the same time. Hey, so you need the shear in order to bend the storm over, and then it can create a kind of almost a circulation, if you will. And so strong wind shear is an ingredient for severe weather and thunderstorms. And then you can also get, you want instability, right? We call it potential energy, CAPE, convective available potential energy. And so that helps the storm rise. So you want, if you want a big thunderstorm and severe weather, you would want CAPE, high CAPE, and you would want shear and a lot of humidity. All right, so that's some of the ingredients. We're going to talk a little more about some of the dangers of lightning coming up. All right, we're back, and lightning, very cool stuff to look at, but unfortunately, it's also very dangerous for you little kids out there. Dangerous stuff. So we're going to talk about some of the dangers of lightning. Let's go into it and switch personalities. So there it is. All right, so we talked about these thunderstorms and how they form. And so, let's talk about it. Deaths, now I don't know, it's not a percentage. This is not a percentage, but the bottom line is this is kind of the number of deaths over a period of time. And so at least you can see it in relation to the others. And you have under a tree, 92 deaths. In water, 69. Yard, 48. Outside the open, 43. So, there's some themes here. Field, 39. On the roof, 18. I'm very surprised about that, but I guess a lot of people may be looking in the distance there. Construction, 10. Par, I assume that's golf. Trail, 8. Parking lot, 17. So these are all. And then inside house, 2. Driveway, 9. And if you get inside, that is key to being safe. So, these lightning strikes, there's one. It's a tree. These trees reach up into the sky. So they're a bit of a helper, right? Because we talked about the step leader reaching down. And so, the trees help that charge get a little higher up into the sky. And so it's an attractor, and a tractor, right? Not a tractor, but yeah. And so it's an attractor. And then same for buildings. They reach up into the sky. They're also lightning magnets. So they've got, lightning rods on top of all those skyscrapers out there and towers so that the building won't be harmed. So some thunderstorm safety rules. The most important thing is to get inside, basically. You can also get into a vehicle. Lightning can strike a vehicle, go down through the metal chassis into the ground. You'll be okay. I've seen on the Weather Channel stories about that where they did some research, and as long as you're not touching any metal, usually the person's okay. But you want to get inside. That's the most important thing, I think. When thunder roars, head indoors. When thunder roars, head indoors. So I had to add a little zest to that. Safest indoors. Vehicles are safe too, as I mentioned. Hard-topped and enclosed cars offer protection. With the soft topper, maybe not so much. Let's take a look at this in full. And so the pool, not a great place to be. If the lifeguards are there, they will make you get out if they see lightning or hear thunder. And then usually they'll wait about 20 minutes. And that goes for the beaches too. They'll make you get out if you're there, I believe. I don't remember if I've been there during a thunderstorm. I think I have, and they make you get out. Anyway, don't hide under a tree, of course. So some lightning safety for inside. You don't want to go to the porch or balcony. We saw the number of deaths there go a little higher. Avoid taking a tub or shower. So you may think, well, why would that be? That doesn't make sense. You're inside. Well, sometimes, rare, very rare, but lightning can strike a tree, go down in the ground. The roots are wrapped around plumbing, and that can come into the house. Very rare, and most of the time you're going to be fine. If you're doing this. But if there's lightning coming down and you got it all over the place, maybe don't then. That's what I suggest to viewers. If you've got lightning all over the place, lightning storm, maybe wait for a little bit to take a shower. Stay off wire devices like a mouse. They got wireless mouses now, but not all of them. And stay away from windows. especially if they have a metal frame. Very important. Bringing the pets. Pets can get struck too, unfortunately. Little doggies. So bring them inside and keep them safe as well. All right, so this is kind of cool. This is a Sprite. A little feature above thunderstorms. Sometimes you get all these electrons, all this electricity. So above the thunderstorm, they can actually get up higher into the atmosphere and create sprites. Very cool to see. And so these sprites, they're short event, milliseconds. I think the light from them lasts a little bit longer, but maybe the electricity from it. Common shapes: jellyfish, carrot. Seen different ones. And research for those is ongoing for the sprites. All right, so lightning anywhere? Yeah, I mean, believe it or not, you can get them in thunder snow. You can get it in a snowstorm. Jim Cantori has been notorious to, have seen a couple live and just react. So, and I met him, really nice fellow. And just, thunder snow, that's rare. Around volcanoes, that can happen, believe it or not. And around forest fires, too. Lightning can happen around forest fires. So heat lightning, is that anything? Is that real? Well, no, it's a myth. No such thing as heat lightning. It's just lightning from a distant storm. It's too far away to hear. So, they get really tall. Sometimes they're, 10 miles tall, something like that. So the light can travel, but the sound is just so far away that you just don't hear it. And so, that happens. 30 to 50 miles away, that storm can be. So some lightning stories. Devonshire, England, 1638, people were struck in a church. There were 3 deaths, 50 injured. And this is out of the book, Out of the Blue, from John S. Friedman. So that's a good little source there. Lee Trevino was knocked unconscious once, the famous golfer. And then 1995, this is sad, Honduras, 70 people killed at a soccer game. And then this is another book that I've got. This is Freaks of the Storm. And this is, there you go, right there. And that's Randy Cervini. And so 1843, Paris, there's ball lightning formed in this shop. Ball lightning is just as it sounds. It's a ball of lightning. It's not huge. It's small. Floated about the size of a human head is what they said. Floated around the room, and then it went up the flue, and all of a sudden there was a loud bang. So there have been stories of this. I have never seen one. I think on video I did, but I couldn't tell if it was faked from a long time ago. But that is really something, that ball lightning. And there have been just so many interesting stories about lightning, stories of clothes blown off, and clothes blown off, stories of ailments, healings, people have been healed, paralysis, and just some amazing stories from lightning. And there was one person that was struck several times in his life. Roy Sullivan, I believe he was struck 7 times in his life. And that's from the same book, and and so this one's interesting. In the book, 1995 in Florida, a man was on a toilet, and lightning struck the tree, traveled through the septic tank, and exploded the toilet. And he was okay. Had high blood pressure and tingling in the lower extremities, quote unquote. So that's pretty interesting. All right, so that's lightning. Let's wrap things up, and the environmental tip of the day. So lump errands together to save gas if possible. Use a bike if possible to get around, and walking, great exercise, good for short distances. Use less fuel, and it's great to get that exercise anyway. All right, that's what we have for today. We're going to end it there, and just want everybody to have a good one. So stay cool and stay away from those lightning strikes. All right.